In this video, you will learn about writing equations of circles. First, let's review the general form of the equation of the circle. It is shown on the top left as x minus h squared parentheses squared plus y minus k parentheses squared equals r squared. And essentially, if we were to summarize, it's x minus the blank squared plus y minus the blank squared equals the blank squared, where the first blank is the x-coordinate of the center, the second blank is the y-coordinate of the center, and the last blank is the radius. So using this information provided, if I want to write the equation of a circle, we know it's always in the form x minus the blank squared plus y minus the blank squared equals the blank squared, where this is the x the center, the y the center, and the radius. So given what we know, the x the center is -1, so I can fill in a -1. The y the center is 2, and the radius is 14. Now if I simplify, because of the fact that I had this minus and -1, we know that that's really plus. So I can make this x plus 1 squared. The y minus 2 I'm going to keep as is. It becomes plus y minus 2 squared. And then equals 14 squared, which if I were to square 14, it would give you 196. So this would be my final answer in standard form. In this next example, I'm going to start with my same general form. So it's x minus the blank squared plus y minus the blank squared equals the radius squared. And I start by filling in the x coordinate, which I know is -2, the y coordinate, which is -4, and the radius, which is 2 square root of 47. Now, when I simplify this, we know that the minus and negative for the x and the y both are going to become plus. They'll become x plus 2 squared plus y plus 4 squared. And then to simplify 2 square root of 47, I can either think of it as 2 square root of 47 times 2 square root of 47, or 2 squared and the square root of 47 squared. But either way, it gives us 188. So I can fill in equals 188 into my equation. Now in the next example, I'm going to write the equation given what I have in standard form. So it's x minus the blank squared plus y minus the blank squared equals the radius squared. And what I can do is if I look to identify a couple of diameters vertically and horizontally go straight across the circle, I can see that I have these two diameters that go directly across and intersect at the center point. So I can assume that this is my center at -3, -1, and the radius is the length of this radius, and we're going by half, so it's 1, 2, 3 units long. So I can fill in the x as -3, the y as -1, and the radius as 3. And if I simplify, I know whenever I have minus and negative, it becomes plus. So I get x plus 3 squared minus -1 becomes y plus 1 squared, and then 3 squared is 9 as your final answer. In the next example, I'm again going to try to find diameter vertically and horizontally, which I have these two diameters that intersect right here, making this my center at 4 comma 2, and the radius is the length of the radius, or the number of boxes here, which is 3. So if I write my equation in standard form, and I fill in the x, the center is 4, the y, the center is 2, and then the radius is 3. So when I simplify, I get x minus 4 squared plus y minus 2 squared, and 3 squared is 9. Now for the next example, I'm still going to write it in standard form. So we know it's x minus the x coordinate squared plus y minus the y coordinate squared equals the radius squared. So if I fill in from what's given, the x is negative 11, the y is negative 3, and we don't know the radius. However, we know that the equation for the area of a circle is pi times the radius squared. So if I set pi times the radius squared equals 16 pi, I can start by dividing both sides by pi. So you get the radius squared equals 16, and then you take the square root of both sides to get the radius is 4. So you can fill in the radius of 4 over here. So now if I make these minus and negatives a plus, I get my final equation to be x plus 11 squared plus y plus 3 squared equals 4 squared, which is 16, as my final answer. So in this equation, I again start the same way to write in standard form. So it's x minus the x coordinate squared plus y minus the y coordinate squared equals the radius squared. So the x coordinate is 3, the y coordinate is negative 13, and the radius squared we don't have, but we know that the area equals pi times the radius squared. So if I set pi times the radius squared equal to 18 pi, divide both sides by pi, you get the radius squared equals 18. And you take the square root of both sides, which if I simplify the square root of 18, it would become 3 square root of 2. So now I can plug in 3 square root of 2 over here. And when I simplify the equation, the minus and negatives become plus. So I'll have x minus 3 squared plus y plus 13 squared. And if I simplify this 3 root 2 squared, again, you can either think of it as 3 root 2 times 3 root 2, or 3 squared times radical 2 squared. But either way, you're going to get your answer is 18. So I can make it equal to 18 as your final answer. For the next example, we start with our formula. So it's x minus the blank squared plus y minus the blank squared equals the radius squared. The x coordinate of the center is 10. The y, the center is 2. And we don't know the radius, but now I know the circumference, which is either 2 pi r or 5 times the diameter. Now if I set 2 pi r equal the 6 pi, I would divide both sides by pi, which gives you 2r equals 6. So I get that the radius equals 3. Or if I say that pi times diameter equals 6 pi, you divide both sides by pi to get the diameter is 6, which then subsequently means the radius is 3. Either way, I'm going to plug 3 in here. So when I simplify, there aren't any signs to change. So it stays as x minus 10 squared plus y minus 2 squared equals 9. In this example, I'm going to start with the equation in standard form. It's x minus the blank squared plus y minus the blank squared equals the radius squared. So the x to the center is negative 14. The y is negative 13. And the radius, I don't know, but I know the circumference is 2 pi root 6, which you can set equal to 2 pi times the radius or pi times the diameter. If I set 2 pi times the radius equal to 2 pi root 6, divide both sides by 2 pi. So these cancel. See, the radius is radical 6. Or you say pi times diameter equals 2 pi root 6. Divide both sides by pi. This gives you that the diameter is 2 root 6. So subsequently the radius is half of that. So the radius is radical 6. So I can plug in the square root of 6 here. And now when I simplify, I change the signs as needed. So these minus and negatives become plus. The x plus 14 squared plus y plus 13 squared equals 6 as your final answer. Now we'll work on converting to standard form we are given equations in other forms. Before we can do that, we first must discuss an algebraic topic called completing the square. What you're trying to do is determine the value of c that must be added to an equation so you can write it as x with something squared. So for example, we know that x squared minus 6x plus 9 is really x minus 3 squared, because the goal is to make it so that we get this term like this. And that value that you always add is always going to be b over 2 squared. We'll talk about that in the next slide. So in a quadratic expression, we always know that it's ax squared plus bx plus c. So the b term in this problem is 36. So if I want to figure out the value of c that you're adding, it's b over 2 squared. This means it's 36 over 2 squared, which gives you 18 squared, which becomes 324. Now the reason this works is because it would be y squared plus 36y plus that 324, which if we factor, so we multiply to 36, or multiply 324 and add to 36, it would be y plus 18 times y plus 18, which gives you y plus 18 squared, and that's why it's completing the square. However, for the terms of this question, our final answer is 324. So if we focus just on figuring out that value c, again, the goal is we always want to find what half of b is and square it, and that's what we fill in for c. So for this case, b is negative 20, so it's going to be negative 20 over 2 squared. So it's negative 10 squared, which is 100. So you add 100 both sides. For this problem, the value of b is negative 17. So it's negative 17 over 2 squared, which doesn't simplify. So it's just negative 17 over 2 times negative 17 over 2. And if I multiply that, I get 289 over 4 as the value I would add for c. For this last one, the value of b is 11. So if I want b over 2 squared, it becomes 11 over 2 squared, which is 11 over 2 times 11 over 2. So it's 121 squared, or 121 over 4 is what you would add to both sides. Now, what completing the square does is it allows us to solve a quadratic. The form that you would use, and you'll talk a lot more about this in Algebra 2 next year, is that you have to first make sure that the coefficient on x squared is 1. If not, you're going to divide the equation to make the coefficient 1. Move the constant term to the right side of the equation. Determine the value that you need to add to both sides of the equation to create a perfect square trinomial. And again, it's always b over 2 squared. Factor the perfect square trinomial, and then take the square root of each side to solve, making sure you consider both the positive and the negative versions. We'll do an example, but again, this is a topic you'll cover much more depth next year in Algebra 2. So in this example, we first move the a value, so the number value in front of the m squared is 1. So I'm going to move the constant over, which means the number without a variable. So I'm going to add 49 to both sides. So it becomes m squared minus 18m equals 47. Now I have to complete the square, which means you need to figure out what you're adding. And again, you add it to both sides so that way we can factor and complete that square. So what we do is we take the value of b and square it. So since we know it's b over 2 squared is negative 18 over 2 squared, which gives you negative 9 squared, which is 81. This means I'm going to add an 81 to both sides. Now what this allows us to do is on the left, I can rewrite this as m minus 9 squared, or m minus 9 times m minus 9. If I add the 47 and the 81, it becomes 128. And then if I keep going, m minus 9 times m minus 9 becomes m minus 9 squared equals 128. And now if I want to solve for m, because of the fact that this is m minus 9 squared, I can take the square root of both sides to solve. And this is why it's called completing the square, and that allows us to solve. Because now I get m minus 9 equals plus or minus the square root of 128. If I simplify the square root of 128, the biggest perfect square that I'll divide into 128 is 64. So when I divide by 64, it gives us 2. This is going to become m minus 9 equals plus or minus square root of 64, square root of 2. So m minus 9 equals plus or minus 8 radical 2. And now I'm solving with two equations. So one equation is m minus 9 equals 8 root 2. And the other one is m minus 9 equals negative 8 root 2. So I have both answers. So to solve, I get m by itself. So I add 9 to both sides. So you get 8 root 2 plus 9 is one answer. On the other side, I add 9 to both sides. And you get m equals negative 8 root 2 plus 9. Again, you'll spend a lot more time learning about this in Algebra 2 next year, but it shows you how you can solve more complex quadratic equations using what you already know. Now, to relate this back to circles, what we have here is we have an x portion and a y portion of this equation. Because if we look here, the x portion is x squared minus 8x. The y portion is y squared plus 6y. So what I have to do is I have to figure out what to add to complete the square so I can factor them. Because I want to make it so it's x squared minus 8x plus something and it's going to be y squared plus 6y plus something equals 39. And again, we're going to add whatever you add for the x portion to the right and whatever you add for the y portion to the right, because I'm adding it to both sides. So when I do this for the x portion, it's b over 2 squared, which becomes negative 8 over 2 squared. So it's negative 4 squared, which is 16. So I'm going to add 16 to both sides. For the y portion, the b over 2 is going to be 6 over 2 squared, which is 3 squared, which gives you 9. So you add 9 to both sides. Because again, whatever number I'm getting here as the result of b over 2 is what is being added to both sides here. And whatever I got here as my 9 from b over 2 squared is what is being added to both sides. So now, if I rewrite this to simplify it a little bit, I get x squared minus 8x plus 16 for the x portion. The y portion is y squared plus 6y plus 9. And then if I simplify the right, I have 39 plus 16 plus 9 gives you that the right side is 64. So now, if I factor these, this is going to be x minus 4 times x minus 4 for the x portion. The y portion becomes y plus 3 times y plus 3 is equal to 64. And now, x minus 4 times x minus 4 can be x minus 4 squared. Y plus 3 times y plus 3 is y plus 3 squared equals the radius of 64. So this gives me my final equation of the circle, which if I wanted to continue graphing, we have the center, this is the x and that's the y, but we switch the equations. So the center would be at 4, negative 3, and the radius equals 8. So for this problem, I'm going to continue what I did in the last question. So I have x squared plus 10x plus something for the x part. The y part is y squared plus 8y plus something, and equals 23 plus the x part plus the y part. So if I want to find the what you're doing complete square for the x part, it's going to be 10 over 2 squared. Its b value is 10. So it becomes 5 squared, which is 25. So I can fill in a 25 on both sides from here. And then for the y part, it's going to be, the b part is 8. So it's 8 over 2 squared, which is 4 squared, which is 16. So you'd add 16 to both sides. So now my equation becomes x squared plus 10x plus 25. The y part is y squared plus 8y plus 16. And then when I simplify the 23 plus 25 plus 16, it gives you 64. So now I can factor. This becomes x plus 5 times x plus 5. The y part becomes y plus 4 times y plus 4 equals 64. So this would become x plus 5 squared plus y plus 4 squared equals your radius of 64, which we know the center, again, this is the x, not the y, the center would be at -5, -4, and the radius is at 8, which you could then graph as needed. In my last problem, I again split it to the x and the y part. So I have x squared minus 12x plus the blank. The y part is plus y squared minus 2y plus the blank. And it equals 12 plus the x part plus the y part. So for the x part, it's negative 12 over 2 squared, which gives you negative 6 squared, which is 36. So you can add 36 to both sides. For the y part, it's negative 2 over 2 squared, which is negative 1 squared, which gives you 1. So you can add 1 to both sides. Because again, I'm taking these numbers I'm adding from the half of b squared and adding it both sides. Now if I simplify, I have x squared minus 12x plus 36 for the x part. The y part is y squared minus 2y plus 1. And then if I combine 12 plus 36 plus 1, you get 49. So now if I factor, it's going to be x minus 6 times x minus 6 for the x part. The y part is y minus 1 times y minus 1 equals 49. So if I simplify, I get x minus 6 squared plus y minus 1 squared equals 49. So your answer here would be that the center is at 6 comma 4 and the radius is 7, which you could then graph as needed.